Hi everyone, this is Sebastian from Robotic. So today I want to show you the tactile sensor. In order to do that, we will use the software interface. So let's start. So as you see here, I have my sensor ready to be used. They are connected into my computer. So I simply select the part and connect to them. So there's the static tactile page. So as you see here, on this page you will see the static sensing forces. So as you see on the graph, you see the force I apply onto the sensor. Please note that you see the graphic here. It seems to have many tactile, but the fact is that we use interpolation in order to do these beautiful graphic. But inside the hood, you really have a matrix of 4 by 7 tactile. Another thing that you need to know is that these sensors are not calibrated to provide a force in Newton. So it is normal that you see only a relative force. But depending on your application, you don't always need to have an absolute force. Another thing that is super important to know is that these sensors have a really great offset on them. If I click there, I see the raw value that the sensor is sensing to me. So this offset, when you want to have a meaningful data, you need to remove it. So at the beginning of your program or testing phase, you need to record what we call the baseline, in order to be able to subtract it afterward, to have only the difference between the basic offset and the force that you will apply on the sensor. So as you see here, the graphic have scale and the baseline has been removed. So we only see the difference here. And this is normal. Also good to know is that this signal for the static part of the sensor is provided at 60 Hz. So you won't be able to have a faster data for the static. It is normal. So let's go to the dynamic part of the sensor. And yeah, one last thing. As you can see, if I apply force on the tactile on the left, I see the result on the left, but the other sensor is working as well. So throughout all the software interface, you see in both column you see both sensor. Okay, for the dynamic part, what is important to know is that you only have one dynamic sensor per sensor. So no matter where I apply force on the sensor, you see that you see the signal. Okay, this is normal. One of the great thing to do with these kind of signal is that if you're trying to figure out an event that has happened on the sensor, normally you will want to have the lowest possible latency for detecting your event. In order to do that, the dynamic signal is provided at 1000 Hz. So that means that you will have the event in the shorter time possible. Okay, so last thing to know, as you see here, you see the raw signal over here, and under it you see the FFT of this signal. So the FFT is the fast Fourier transform. Depending on your application, you may want to use this spectrum instead of the raw data. Example, if you do classification or stuff like this. So let's finish with the IMU. So the IMU is simply an inertial unit that is measuring acceleration. So basically you have acceleration in linear axis, So if I want to measure acceleration in this axis, you see the signal that is responding to it. And under here, you have the gyroscope value, which is the rotational acceleration. So if I want to show you, as you see, the accelerometer value are almost not moving, but you see the gyroscope part, which is moving pretty strongly, have a strong signal. Same thing if I put the sensor on other axis, or like that. So that can be useful to figure out what is happening in your application. So let's finish with the gravitational force. As you see here, the linear accelerometer are seeing the gravitational force of the Earth. So if, depending on your application, if you want to figure out the angle of the gripper tips, you may want to use this force. So last thing, the logging part of this software. If you want to log the data, you simply have to select an empty file. Let's say on the desktop, I already have my logging file ready. So I simply select it, and yeah, and simply start logging. So as you see here, currently I'm logging data. So if I apply force and then stop logging, I can go open LibreOffice in my case, as you see here. Yeah, just edit that, and then open the file into LibreOffice. Yeah, so you see the dynamic signal, which is, as I told you before, is refreshed at 1000 Hertz. You also see the static data of all the 28 Tactile. These sensors are not refreshed as fast, as I told you, at 60 Hertz. So this is why you see the same value for a while and then an updated value, and it's going on like this all to the bottom. And you can see also the IMU value here. So that's it for this video. I hope it will help you to quickly start your application. Don't forget that you have other option to interface with the sensor, as you can see on the DOF post. Go there and you have the ROS package, and you can also develop your own communication stack if you want to, with using the communication protocol documentation that we provide on the DOF post as well. So thank you, and have a good day.